Okay, so we're always hearing about how amazing these large language models are, these LLMs, but it kind of feels like trying to figure out what's going on inside is like staring at a brick wall. You can't see through it. But you sent us something that might actually give us like X-ray vision into these things, a platform called ReasonGraph.
Yeah, exactly.
Yeah.
That was a really interesting paper, Lidl.2025 ReasonGraph visualization of reasoning paths.pdf that you shared. And it gets right at, I think, a really fundamental challenge of trying to understand how these LLMs are thinking.
It's so true because we've got these AIs producing these crazy complex texts. But when you want to know how they actually got there, how they reasoned their way to that output, it's a total mystery. You just see the answer, not how they got there.
Yeah.
And that's what ReasonGraph is trying to fix, right?
Exactly. And what this paper does so well is they really focus on this problem that we're all kind of drowning in this sea of text output from LLMs. And that by itself makes it really hard to grasp how they're reasoning.
It just creates what they call cognitive overload. I mean, our brains just aren't meant to process this much sequential information easily and actually pull out the logic from it.
Yeah, let's talk about that cognitive overload for a sec.
Yeah.
Like, imagine you're trying to follow this super complicated debate.
Right.
But instead of actually hearing it, you just get pages and pages of transcripts all mixed up.
Yeah.
Good luck figuring that out.
Yeah.
You'd miss all the important connections and never understand the flow of the argument.
Exactly. It's like the paper says, without that visual element, it's just so much harder to follow the reasoning and all the different ways these LLMs can get to a conclusion. It's like trying to understand a symphony just by looking at the musical notes without the score.
And it's not just about how hard it is to think about it that way.
Yeah.
If you can't see the logic visually, then you're way more likely to miss errors too.
Oh, absolutely.
If an LLM makes some illogical jump or has some circular argument buried in pages of text, good luck finding it, right? That's the second key point the paper makes. Yeah. Error detection becomes a nightmare. You might have something that sounds totally reasonable, but the logic underneath could be totally flawed and you'd never know just from the text. But if you had a visual representation, those mistakes would probably jump right out at you.
Like a giant flashing neon sign.
Exactly.
And the third thing the paper talks about is how not having a standard way to visualize this stuff is actually holding back progress in the field. If everyone's just working with raw text, it makes it much harder to develop better ways for LLMs to show their reasoning and build better tools on top of them.
Yeah, it's the big picture.
Yeah.
If we had a common way to visualize how these LLMs reason, we could make huge leaps in how they show their logic and how we interact with and build on their capabilities.
Right.
And ReasonGraph is really trying to step into that gap.
So let's talk more about what ReasonGraph actually is. What does this thing look like and what can it do?
Okay, so at its core, ReasonGraph is a web-based open source platform, which is huge because it means anyone can collaborate and contribute to it. What it does is take those often hidden reasoning steps of an LLM and turn them into these visual diagrams.
So instead of walls of text, you get actual pictures of how the AI is thinking, like flow charts or mind maps.
Exactly. And what's really cool is that it can visualize both sequential reasoning, which is where the LLM goes through steps one after the other, and tree-based reasoning, where it might be looking at a bunch of possibilities at the same time, kind of like a decision tree.
So this sounds like it needs to be able to work with a ton of different AI systems. Does it actually work with all the big ones?
It does. It's really impressive. They talk about how it works with all the major LLM providers, Anthropic, OpenAI, Google, and Together.ai. It even works with a surprising number of models, over 50 according to the research.
So no matter what model or provider you're using, ReasonGraph can still give you that behind-the-scenes peek into its reasoning.
That's the idea. And from what they describe, the user interface seems pretty user-friendly. You can choose which reasoning method you want to visualize or even have the system suggest one based on what the LLM is doing, and you can control.
So you can actually customize how the visuals look.
Exactly.
That's super useful, especially if you're dealing with really complex reasoning. You could zoom in on certain parts or move things around to make it easier to understand.
Right. And they built the whole thing using a modular design.
Yeah.
That's like using building blocks.
Okay.
Which is great because it means they can add support for new LLMs and new reasoning methods as they come out.
Makes sense.
Yeah.
So we've got a good handle on what ReasonGraph is. Now let's talk more about why this visual approach is so important. We touched on cognitive load error detection and how it can lead to new applications. Let's go a bit deeper on each of those.
Okay, let's start with cognitive load. like we were saying, trying to decipher complex reasoning from just text. Really hard on the brain. The paper references their earlier work, which I'm guessing goes into a lot more detail.
Okay.
But the main idea is that our brains are just way better at processing visual information.
Yeah.
Especially when it comes to understanding relationships and flows and hierarchies.
It's kind of obvious when you think about it, right? A good diagram can communicate so much so much faster and clearer than pages and pages of text.
Absolutely. It lets you instantly see the connections in the structure without getting bogged down in all the words.
Okay, so you're saying it basically lets you see the connections between the different steps in the reasoning and compare all the different paths the LLM might have considered.
Exactly.
And it makes it much easier to see the big picture logic without getting lost in the details.
Yeah, and this is especially helpful when you're trying to understand the differences between different reasoning methods.
Makes sense. Now, how about error detection? How does actually seeing the logic help us find errors in how the LLM is reasoning?
Think about it like this. Imagine you're looking at a logical fallacy, something like affirming the consequent, buried in a giant block of text that could be really hard to spot.
Yeah.
But in a visual graph, that mistake might show up as a really obvious illogical connection or a branch leading to a conclusion that's just hanging there with no support.
Yeah.
It's like having the blueprints for an argument and noticing there's a support beam missing.
So it's like a visual debugger specifically for LLM reasoning.
Exactly.
You can actually see the structure of the thought process and find any weak points or flaws.
Precisely. It lets you examine the logical framework that the LLM is using and pinpoint any areas where the reasoning might be shaky or incomplete.
Now, how does having the standardized visual representation, like you were talking about earlier, open the door to new and better LLM applications?
Once you have a consistent way to see how these LLMs reason, it lets you build much more sophisticated tools that can work with and analyze that reasoning. For example, you could have AI systems that automatically scan these reasoning graphs, looking for common error patterns or suggesting better ways to reason or even learning from the successful pathways.
So we could actually help the LLMs become better reasoners.
Right. It's not just about us understanding them better. It's about helping them reason and communicate more effectively in the future.
A two-way street. So let's get into the specifics of how ReasonGraph actually creates these visualizations.
Okay.
The paper breaks it down into tree-based reasoning and sequential reasoning. Let's start with tree-based methods, like beam search.
Yeah, beam search is where the LLM is exploring a bunch of potential solutions at the same time, keeping the best ones and moving forward with those. And ReasonGraph shows each of these steps as a node in the graph. Each node also has a score attached to it that shows how promising that direction looks to the LLM. As the reasoning goes on, these scores get added up along each path.
Got it.
And the one with the highest total score at the end becomes the final answer.
So you'd see all these different branches with their scores, and the best path would be highlighted somehow.
Exactly. The paper mentions that they keep the width of each level in the tree consistent, which gives you a clear view of all the possibilities. And they use things like different colors or line styles to make the final chosen path really stand out.
That's so much better than trying to follow all that in a jumbled text output.
Right. You can instantly see the decision points and compare how strong the different options are.
They specifically compare this with text output in the paper.
They do. They talk about how much easier it is to understand the layout right away.
Yeah.
To quickly see the key decision points and to directly compare different paths. The paper also briefly mentions tree of thoughts. With another tree-based method. They point out that ReasonGraph's focus in visualizing beam search is on how the scores lead to the best path, whereas tree of thoughts visualizations often highlight the wider exploration of the problem space with different levels of branching.
Makes sense. So that's tree-based reasoning. What about sequential reasoning methods?
Yeah.
Where the LLM follows a more linear step-by-step process.
So for that reason, Graph uses directed graph layouts. They basically show the reasoning process flowing from one step to the next. Figure 3 in the paper has some great examples.
I'll have to check that out. So what about a method like chain of thoughts? That one's become really popular, right?
Yeah, chain of thoughts is visualized as a straight line, basically. Each deductive step leads directly to the next one until you get to the final answer.
Nice and simple. What about some of the other sequential methods they talk about, like self-refine?
Yes, self-refine is where the LLM makes an initial attempt and then keeps refining it based on its own feedback. And they show that with loops in the graph.
Okay.
These loops represent those cycles of reflection and improvement. And they even use yellow boxes to highlight those self-reflection parts, which makes it really easy to see how it's different from a basic chain of thoughts process.
So it visually distinguishes the different approaches.
Exactly.
Yeah.
What about least to most?
What's that one?
Least to most is when you break a complex problem down into smaller sub-questions.
Yeah.
And then solve those one by one. They visualize that with a kind of layered structure.
Okay.
Where the original problem and the sub-questions are shown in one color, and then the answers to those sub-questions are shown in a different color. It really shows how the LLM is tackling the problem, step by step, building up the solution.
Okay, and what was that last sequential method they talked about, self-consistency?
Right, self-consistency is where the LLM generates multiple different lines of reasoning at the same time, and then picks the answer that's most consistent across all of them.
Interesting.
And they visualize that with multiple paths that all converge on a single final answer.
I like it. It's a nice visual representation of that idea of exploring multiple possibilities and then coming to a consensus.
It seems like they really put a lot of effort into figuring out how to visually represent all the unique parts of each reasoning method.
Definitely. Now let's get into the technical side of things. How does ReasonGraph actually work under the hood?
Okay, so they describe it as a modular framework with a bunch of different pieces working together.
Okay.
There's the front end, which is what the user sees and interacts with.
Right.
The user interface, all the buttons and displays. That part uses asynchronous event handling. So when you do something, the system responds dynamically. They also use a JavaScript library called mermaid.js to actually draw the graphs.
Oh, cool.
That lets them create and update the visuals in real time. It's kind of like a translator.
Okay.
That turns the reasoning steps into pictures you can understand.
So the front end handles the user experience and the visuals. What about the back end?
Yeah, the back end is where the heavy lifting happens.
Right.
It's built using the Flask framework, which acts as a central organizer for all the different parts. They've got it structured into three main modules. There's the configuration manager that handles the application settings. Then there's the API factory that manages the connections to all the different LLM providers.
So it's like the communication hub.
Exactly. And finally, there's the reasoning methods module, which contains all the logic for implementing and visualizing each of the reasoning approaches we've been talking about.
So how do all these different modules talk to each other to make sure everything runs smoothly?
They use a RESTful API, which is a standard way for software components to communicate over the internet.
Okay.
It ensures reliable connections and has built-in ways to handle errors.
That makes sense. And the paper mentions that this modularity isn't just at the API level, but also within the reasoning methods themselves.
Right. So if they want to add support for a new LLM or a new reasoning technique, they don't have to rewrite the whole platform. They can just plug in a new module.
That's really smart. So if a brand new super advanced LLM comes out tomorrow, they can just add a new module to the API factory and boom, they're ready to go.
Right. And it works the same way for the reasoning methods. Each one is its own module with a standard API that lets it take the LLM's output and turn it into the visualization.
So they can easily switch between different providers and methods and keep the platform up to date.
Exactly. And that makes it super adaptable to any advancements that happen in the field.
This whole thing sounds incredibly well thought out and flexible.
Yeah.
Where are we actually seeing ReasonGraph being used in the real world right now?
The paper highlights three main areas where it has a lot of potential: academia, education, and development.
Okay, let's start with academia. How can ReasonGraph be used for research?
It gives researchers a really powerful tool for dissecting the reasoning processes of different LLMs.
Okay.
They can compare the effectiveness of different methods and objectively evaluate the capabilities of different models on a variety of tasks.
So it could revolutionize how we evaluate AI, right?
Right. It's not just about accuracy anymore. It's about understanding how they reason.
Yeah, and how reliable that reasoning is.
Exactly. What about education? How could ReasonGraph be used in the classroom?
I'm actually really curious about this one. It seems like it would be a fantastic way to teach students about logic.
Yeah, absolutely. Imagine being able to see exactly how an AI reaches its conclusions.
Wow.
It would make the concept so much more concrete and engaging.
It would definitely be way more interesting than just reading about it in a textbook.
And it could help students really understand both the strengths and limitations of these models in a hands-on way.
Okay, and lastly, what about its applications in software development?
For developers who are building things with LLMs, ReasonGraph can be incredibly useful.
Okay.
They can use it to fine-tune their prompts, seeing how different prompts affect the LM's reasoning path.
Yeah.
They could also use it for debugging.
Yeah, that makes sense.
Because it shows them exactly where the reasoning might be going wrong.
Yeah.
And as we discussed earlier, it can help them choose the best reasoning method for a particular task based on how it's visualized.
So it's not just about understanding AI, it's about building better and more reliable AI systems.
Exactly. Now, in terms of how well ReasonGraph actually performs, they tested it on 3 main things.
Okay.
Parsing reliability, processing efficiency, and platform usability.
Okay, so let's go through those one by one. Starting with parsing reliability. How good is it at understanding what the LLM is actually outputting?
So they used a rule-based XML parsing method, and it was able to extract the reasoning paths from well-formatted LLM outputs with almost 100% accuracy.
Wow, almost 100%. That's pretty impressive.
Yeah, it shows that it's really good at interpreting what the LLM is doing.
Okay, what about processing efficiency? Is there a big lag when you're generating these visualizations?
Not at all. Their research shows that the time it takes to actually generate the visualization is basically nothing compared to how long the LLM takes to reason through the problem.
So it's super fast.
Yeah, and that's really important for a smooth user experience. Nobody wants to be sitting there waiting for a diagram to load.
And lastly, what about platform usability? How easy is it for regular people to use?
So they got some initial feedback from users of the open source platform.
Okay.
And around 90% of them said they could use it without any help.
That's a good sign. It sounds like it's both powerful and user-friendly.
Yeah, but they also mentioned that they're constantly tracking and improving those usability metrics.
Makes sense. Is there anything else we should keep in mind?
There is one thing. They point out that how well ReasonGraph works overall depends on the LLM actually following the instructions it's given.
That makes sense.
If the LLM's output isn't structured correctly, it could mess up the parsing accuracy.
Right.
But their rule-based approach seems to be pretty robust.
Okay, so as we wrap up this deep dive, what's the key takeaway for our listeners?
The big thing to remember is that ReasonGraph is a huge step forward in demystifying how these large language models reason. It gives us a way to actually understand how they're getting to their answers.
Right, instead of just treating them like magic black boxes.
Exactly.
So whether you're a researcher trying to understand how AI works or a student learning about logic,
or a developer building LLM-powered applications, ReasonGraph can give you a whole new perspective.
It can help you debug your applications more effectively, optimize your prompts, or just satisfy your curiosity about what's going on inside these powerful models.
It's also open source, which is awesome.
Yeah, definitely. You can find the GitHub repository at https://github.com/zongqianli/ReasonGraph.
Perfect. We'll be sure to include that link in our resources.
Yeah.
So thinking about the future, this ability to actually see how AI reasons is pretty mind-blowing. What do you think this increased transparency will mean for our trust in AI?
That's a good question.
As AI becomes more and more integrated into our lives, will this make us more likely to rely on it? And what about all the new reasoning methods and models that are coming out?
Right.
What kind of insights might we gain about the very nature of intelligence?
Yeah, it really makes you wonder.
As we start incorporating them into platforms like ReasonGraph.
It's definitely something to think about. And it shows just how important it is to have tools
that help us not just use, but truly understand these increasingly complex systems.
Couldn't agree more.
Yeah.
Well, this has been a fascinating deep dive. Thanks for joining us.
My pleasure.
We'll see you next time.
See you then.